So this is the demo of object detection with the Nvidia Jetson onboard camera. So we've used YOLO for this purposes, and if you just open the GitHub page, YOLO with Nvidia Jetson TX2, you'll see all the necessary things that you need. So I'm not going to go into details of the implementation over here because it itself is a huge model, but just let's go through a quick overview. So the input image is going to be 608 by 608 by 3. We have to reduce the dimensions through a you know a, a deep network which reduces the dimensions by 32, so you get 19 by 19 by 425. Why 425 is actually this. So with YOLO I'm taking 80 classes, so 80 different classes such as uh, say a car, signal and whatever, and if you actually run through the code you will see that. Then the first one is the score of actually that box 19 and 19 box having the having a particular object, and this is actually the borders of that object that we are predicting. uh, so for this you actually then you'll predict a bunch of um, probabilities and bunch of boxes. So how do you actually narrow down to the best ones? So you use hard thresholding and you use non-max suppression. So for non-max suppression, what it means is that if this is my image and I have two such boxes, then how do I determine this area is by this formula, intersection over union, and I keep only one box out of both of them. So this is non-max suppression, which gives me the best box. Again, I've used OpenCV for actually taking in the image from the Jetson camera, formatting it in the way we need, and feed it to the network to predict. The implementation of Jetson, the YOLO model over here is pretty huge. The model itself is in keras, and the loss functions and the non-max suppression is in Tensorflow. So this model is pretty slow. So what we actually did is, for demo, we downloaded the darknet version of it, the tiny version of the YOLO model, and these are the instructions for it. So just follow these commands. The important thing is that to make this changes of GPU, CUD and then OpenCV to 1, because then only we can use the onboard GPU that we have on the Jetson. You have to set this to 62 for TX2, for 53 for TX1, 53. Again, I'm using the tiny model right now, so it's pretty light. It goes awesome. It may not be the best in accuracy, but it is really, really cool. The datasets, there are tons of datasets for YOLO or object detection available on the web. You can just Google it and you'll find like 10 or 15 at least. I've given you a sample link from where you can download. So after you do all the steps, just run the test on cam.py file, and you will. In that, I'm running a demo of going from Santa Monica to Venice Beach here in LA. So let's see. You can just uncomment the paths for onboard camera in that file. So here I'm predicting, which is pretty smooth, what is actually happening. It's not exactly accurate, the shapes, but it's running pretty smooth, and that's the beauty of the tiny model of YOLO. Again, if you want the exact accuracy, then obviously I suggest you use the entire model that we have developed. But if this is fine for an onboard thing that you want to do, then this is really, really cool. Again, I've not attached any SSDs or anything with the Jetson. This is just running on Jetson onboard memory, and if you see, I'm utilizing not a huge, like 66% of it. So with resonance we saw that it was going up to like 95%, and it was running out of memory, but this tiny version can be run pretty smooth without any external hardware. So you can also include your custom objects in the YOLO. Just include it images of that class, and then your input dimensions, the output dimensions will be a bit different. Here you have 80 classes, you will have 81, 85, whatever you have, and it can be pretty much done. Thank you.